immediate insights into the presence of nanoparticles at ultra-low concentrations.
Nanoparticles, lasers, and liquids. How do these go together? Well, like you, I'm full of questions. Hello, my name is Keith, and together with you, I would like to explore how nanoplastic particles can be detected and measured in liquids with OF2i. To better understand the research field and its intricacies, I've invited Assistant Professor Dr. David Clases from the Nano Micro Lab of the Institute of Analytical Chemistry. So let's jump right in. Hi, David.
Hi, Keith.
Thanks so much for taking the time to speak with us today.
Yeah, thanks for having me.
Can you please tell me briefly what you're investigating?
Absolutely. So we're from the Nano Micro Lab. We're interested in detecting different kinds of nanomaterials as well as micromaterials in the environment as well as in biological tissues. And we are at the moment quite interested in looking at nanopollutants, how they behave in the environment and what their fate is.
So what you're trying to do is find out more about these contaminants.
Yeah, well, before actually interrogating them, we have to make sure that we can accurately detect them. And that is actually a major challenge in our daily life. And we are depending on methods which are highly sensitive as well as very selective. And in our case, we're using a technique called inductively coupled plasma mass spectrometry. And in this case, we are trying to detect them individually, to count them, to characterize them in regards to elemental compositions, to learn more about their size, composition, as well as about their masses.
So I guess this is where Brave Analytics comes into play. With OF2i, they invented a method to study very low particle concentrations in liquids. Come on, let's go have a closer look at their experiments.
Sounds good.
So, David, this is the Brave Be Curious laboratory device. Together with one of our scientific partners, Brave Analytics undertook different test series to measure the plastic particle contamination and leaching processes of different plastic bottles made of polypropylene and compared them to glass bottles.
In the experiment, they sterilized the bottles according to the manufacturer's recommendations and performed various cleaning procedures using 20 nanometer filtered ultra-pure water. Immediately after this procedure, the OF2i measurement was performed, as no further sample preparation was required. After taking the baseline concentration, the team measured the particle concentration in glass and plastic bottles. Interestingly, they discovered different contaminations are seen for different cleaning procedures. They repeated the procedure with different plastic bottles and can see a significant decrease in particle concentration after 3 cleaning processes. The concentration of glass bottles was measured and plotted together with the reference filtered water. Now, let's see how David prepares the sample for a similar measurement.
There you go, David.
Thanks.
All you have to do is fill up that bottle with some ultra-pure water.
Here you go. Just. Good enough?
Perfect. Now,
Thank you.
give that a swirl.
Like this?
Perfect.
Okay.
Fill up that glass vial.
Thanks. Thank you.
Excellent. And now the Brave Be Curious does its magic. The light forces known from optical tweezers cause the particles to be optically trapped. Brave Analytics uses these forces to measure but also focus and increase particle concentrations. We can even trap the particles and spatially separate them, referring to their size or optical properties. With, for example, polypropylene particles, in trapping mode, the particle size actually determines the location of the particle in the measuring cell. Particles can be trapped, analyzed, separated, and concentrated over time before eluting them for further measurements. How does this sound, David?
That sounds fantastic, and I think that's exactly what we need. So I would be very intrigued to see if we can use your technology and hook it up with our single particle based mass spectrometry and start describing particles from different angles.
Me too. Sounds great. Particle concentration and their distribution in liquids, even at very low concentrations, are not the only results provided by the OF2i. Its active measurement principle allows for trapping, concentrating, and observing leaching processes of smallest particle concentrations over time. Wouldn't it be great to analyze their composition? Let's see what the brave future brings. Smell you next time.